In this video, I am trying to demonstrate how to use vernier calipers or slide calipers in order to determine the dimensions of different objects. Coming to the construction of vernier calipers will be having a main scale which is attached to a jaw, may be called as a fixed jaw, and it will be having a vernier scale attached to another jaw which may be called as an movable jaw. See, this vernier calipers can be used to determine both the internal and the external dimension of an object. Suppose if we are using this vernier calipers to determine the external dimension of an object, then we have to use the lower part of the jaws and the object has to be placed like this. Suppose if you have a hollow object like this and if you are trying to determine the internal dimension of an object, then the upper part of the jaws are to be used and the object has to be placed between the jaws like this. The graduations of the main scale and the vernier scale are to be explained, and as you can see here, the main scale is, the lower part of the main scale is graduated in centimeters. This is the 0 of the main scale. 1, 2, 3 represents 1 centimeter, 2 centimeters on the main scale, and the vernier scale will be having 10 divisions which are equally spaced. The value of 1 MSD can be determined like this: 1 centimeter on the of the vernier main scale is divided into equal 10 divisions. Therefore, value of 1 main scale division will be equal to 1 centimeter divided by 10 will be equal to 0.1 centimeter, or it can be 1 millimeter. And if I just coincide the 0 of the main scale and the vernier scale, we can see here the 10th division of the vernier is coinciding with the 9th division of the main scale. It means that 10 divisions of the vernier will be equal to 0.9 centimeter. Therefore, the value of 1 vernier scale division will be equal to 0.9 divided by 0.9 divided by 10 will be equal to 0.09 centimeter, or it will be 0.9 millimeters. Now, if we are using this calipers to determine the dimension of some object, and while determining the dimension of an object, if the position of the vernier calipers is like this, then we have to notice two different readings. One is a main scale reading and another one is a vernier scale reading. In this case, to recognize the main scale reading, we have to concentrate on the 0 of the vernier. The 0 of the vernier is lying between the two divisions of the main scale, that is between 1.4 and 1.5. When the 0 of the vernier lies between the two divisions, then we have to take the lower value or the least value. Therefore, the main scale reading in this case is 1.4 centimeters. Suppose if the main 0 of the vernier is exactly coinciding with any one of the main scale reading like this, then the main scale reading will be equal to 1.3. In this case, as you can see, the first division, that is the 0 of the vernier, is exactly coinciding with the 1.3 of the main scale. Therefore, the main scale reading is equal to 1.3 centimeters. Now, how to identify the vernier scale reading? Vernier scale reading is, suppose for this position, if the main scale is equal to 1.3 and we have to see which among the 10 divisions is exactly coinciding with any one of the main scale division. The main scale is 1.3 and the best possible coincidence of the vernier is second division. Therefore, the reading has to be taken as 2. Main scale is 1.3 and the vernier scale is 2. Now, I will be trying to explain you how to determine the least count of an vernier calipers. See, there are two methods to determine the least count of a vernier calipers. First, I will define you what is meant by least count. Least count is the minimum possible value that can be measured using any instrument. See, in the method 1, the formula in which we are using to determine the value of least count is equal to value of 1 MSD divided by the total number of divisions on the vernier scale. I have shown you the diagram of both the main scale and the vernier scale here, and I have also explained you the value of 1 MSD of the vernier calipers is equal to 0.1 centimeters, and we have 10 divisions on the vernier, that will be 0.1 centimeter divided by 10 will be equal to 0.01 centimeter or 0.1 millimeter. Coming to the second method, see, the value of 1 MSD again remains the same, which will be equal to 0.1 centimeter. I have shown you that on the instrument, the 10 divisions of the vernier will exactly coincide or end at the 9th division of the main scale. Therefore, value of 1 vernier scale division will be equal to 0.9 divided by 10, which we will be getting the value 0.09 centimeters. Therefore, the formula in which we are using here is least count is equal to value of 1 MSD minus value of 1 VSD. Value of 1 MSD is 0.1 centimeter and value of 1 VSD is 0.09 centimeter, which will be giving us a value equal to 0.01 centimeter or 0.1 millimeter. Whether you adopt the method 1 or the 2, you will be getting the same least count. Now, the formula to find out the total reading is given here. The total reading is taken as the sum of MSR plus CVD into least count. Suppose in an example, if the main scale is equal to 1.6 and CVD is equal to 7, then the total reading will be 1.6 plus 7 into 0.01, which will be giving you 1.6 plus 0.07, which will be equal to 1.67 centimeter. This is how we will be using the vernier calipers to determine the dimension of any objects.